Welcome to Fundamentals of Artificial Intelligence. Today we will review knowledge representation and reasoning, particularly to motivate the introduction of formal logics as a knowledge representation formalism for artificial intelligence. Knowledge representation and reasoning forms the backbone of any intelligent behavior through computational means. In fact, human intelligence is also driven through knowledge. Most complex and mysterious phenomena is the intelligence that humans exhibit. But the striking aspect of intelligent behavior is that it is clearly conditioned by knowledge. Decisions for a wide range of activities are based on what we know or believe. Intelligent behavior that we arrive through computational means, knowledge representation and reasoning, allows an agent to decide what to do based on what it knows. What is important for such a system to be in place is to have structures for representing the knowledge and then certain computational processes for reasoning with those structures. This is what we will look at today and try to motivate how formal logic forms a very interesting choice to be taken up for representation of knowledge in AI. But then what is knowledge? In order to understand knowledge, we start with the basic definition of what we mean by data. Data is primitive verifiable facts of any representation, and data reflects the current world. Data is often voluminous and it is frequently changing. As you process data, you get information. So any interpreted data is information. Knowledge is one step ahead of this. It's about the relation among sets of data that is very often used for further information deduction. Knowledge is, unlike data, general, and knowledge contains information about behavior of abstract models of the world. Now, from the very beginning of AI, there has been two approaches to look at artificial intelligence. One believed that developing an intelligent system was to be based on rules and knowledge, and any intelligent behavior is actually manipulation of symbols. This approach to AI is called the symbolic AI. So the traditional symbolic approach was introduced by Newell and Simon in 1976 and describes AI as the development of models using symbolic manipulation. Then there is the other approach to AI, which is called connectionist AI. The connectionist AI strives to build a computational system inspired by the intricacies of the human brain. We will not go into the details of whether symbolic AI or connectionist AI is going to win the race of creating an intelligent system, but then we like to point out that there is a realization that there needs to be some convergence of both the approaches to really have an interesting intelligent system in place. We will neither talk of that convergence here and only focus our attention on symbolic AI. So knowledge representation that's based on the knowledge representation hypothesis is an essential problem of symbolic based artificial intelligence. The knowledge representation hypothesis put forward by Brian Smith in 1982 states that any mechanical embodied intelligent process will comprise of structural ingredients that will represent somehow the propositional account of knowledge, and independently of such a formal semantics will play formal and causal role in performing the behavior that manifests the knowledge. The symbol system hypothesis is a position in the philosophy of AI which was put forward by Alan Newell and Herbert Simon the physical symbol system hypothesis states that the necessary and sufficient means for general intelligent action is a physical symbol system. Now, there are two things to observe from this statement. One, that human thinking is a kind of symbol manipulation, because the symbol system is necessary for intelligence. That's what they have stated. Therefore, we could say that human thinking is a kind of symbol manipulation. The other is that because a symbol system is sufficient for intelligence, we could have machines that can be intelligent. According to the symbol system hypothesis, knowledge may be represented as symbol structures. Essentially, we would have complex data structures representing bits of knowledge. Like I would be talking of objects, concepts, facts, rules, strategies, and we could use different representations to show what we mean by these different things. For example, I could use a string like red to represent the color red, or I could use a string like car 1 to represent my car. And then if I write a very simple statement like red car 1, I would then be able to immediately see that this represents the fact that my car is red. Intelligent behavior thereafter can be achieved through manipulation of those symbol structures. Therefore, it's important for us to answer two questions. One, how do we represent this knowledge in form of structures, and how do we implement the process of reasoning? In order to understand this, let us first try to understand what we mean by representation.